Start. Right, so good evening, everybody. Welcome to the Essex Network IET lecture this evening, given by Paul Meenan on the latest copy of the wiring regulations and why they're necessary. Any questions we'll take at the end, so if you could type those in to the Q&A button. We may well need to summarise or even combine some of those questions at the end if we get too many or a number that are very similar. But we'll try our best to go through as many as we can. So without further ado, I'll hand over to Paul to start his presentation.
Okay, thank you, Rob. Okay, hello everybody. My name is Paul Meenan. If you do not know me, I will do a quick introduction and we will get aboard the roller coaster. So today we're going to be talking about BS 7671 Amendment 2, the big brown book. Before I get onto it, my name's Paul. I am an asset manager for mechanical and electrical systems on a wonderful little railway. I work for a company called Trenitalia. I also, in voluntary capacity, am the chairman of the Electrical Safety Roundtable, which covers workplace safety. I am an IET volunteer, PRA, PRI, EngTech assessor, and EngTech elect. And I also, with a group of friends, do a voluntary thing called E5 Group, which we'll cover later on, but we're on Instagram and YouTube. Right, let's get started. So this is trying to stimulate a thought process. Everything about this today is, I'm assuming most of the people watching have a level of good electrical understanding, whether you're a learner or you're a seasoned veteran. I can't go through all the changes because there's so many. And while reading this book, I found a weird, unique thread that popped into my brain of everybody's talking about net zero. This is a really important benchmark standard. Why don't we talk through some of the key changes and some of the quirky stuff around it, and then take us into maybe where we need to be looking to understand more about net zero. You won't understand it fully from this, but please, if we don't get around to any answering in the Q&A today, if you leave it in the YouTube comments, I'm sure we'll eventually get around to answering it. So take you back, because I'm a history nut. 1882, Society of Telegraph Engineers and Electricians. They needed some rules and regs to prevent fire, which is still a key thing today, really. That's kind of what we try and do, protect people and property and reduce fire. All because of this wonderful thing called electric lighting, which came out, and that's obviously a copy. The front page of the wiring regs came out on a foldable 3-page booklet originally, and was handed out at a society meeting, and it had 21 rules. That was it, and a couple of notes. If you want to know more about that, there is a webinar online that covers the entire history of the first edition. So most people who may be familiar will be very familiar with the 18th edition. Came out in 2018, which is the big blue book. And since then, over the last few years, we've had Amendment 1, which was specifically regarding EV charging. And we're now on to the big brown book, which after a few corrigendums is now a really interesting development. I think it's an improvement. I think it's one of the best editions we've done in some years. Now, the first edition, just to give you a little bit of context, 1882, it had 4 parts, 4 pages on the reprint. The current version, since it's become a British standard, 8 parts now. It used to be 7, 608 pages we're up to now. So it's growing and growing and growing and growing, and it will continue to. Released 28th of March, so not too long ago. We can implement it immediately, but in a year's time, everything's kind of expected to comply. Although on the bigger commercial industrial jobs, if you've got a contract and there's a design freeze, not necessarily so. There is a phrase that's caused a bit of concern and controversy. Support for 7671 will be withdrawn in 6 months after the release. That doesn't mean the old regs don't exist in the world anymore. It just means that support for that standard. We can always be brought into a court of law and prosecuted against a previous edition of the regs, and they'll use the current to even further question us. So no edition of wiring regs ever truly disappears. If I wanted to, I could design a wiring system for one of my railways to the 17th edition. However, I would have to write a lot of risk assessments, do a lot of departures, and be very good at explaining why I would do that. General consensus is go with these new regulations because they are about improvements, lessons learned, enhancements of technology, and safety events that have caused these regulations to improve. Before we get into the actual changes, though, one of the key changes that's very important in the understanding and arguing around this big brown book, there are lots of the various verbal forms that are used in standards, and this is one of the new parts at the start of the book. You will hear the term from many a person, normative and informative, which is on the right side there. Normative means it's part of the standard. Informative means it's guidance. So when you see a shall, like you would see a shall in the electricity at work regulations, you will do it, you will follow it. If it's a should, it means it's kind of optional. Just use it as guidance and as additional information to support your application of your engineering knowledge. Another thing that is said frequently by my peers in the IET, the wiring regulations is it's not the ceiling, it's the floor. This is a minimum standard you work from when you're applying your engineering judgment. You may find standards that conflict or enhance these requirements. So if you find you're arguing over an application of a regulation, you might want to stop and think and go, is there a true understanding of these requirements? So we'll jump straight into part one. There is a new term. So obviously in part one, regulation 11012 has what's included in the regulation, and it introduces a term I'm going to say repeatedly, prosumer. Introduces prosumers, low voltage electrical installations, and that includes external buildings. No doubt in 10 years time, there'll be a building regulation telling us to put battery storage outside the house rather than inside, mainly because of fire risks with batteries, but I'm sure that will take 10 years to come out. And by the way, for anyone who's asking or thinking this will be on YouTube, part two, there is more changes, but I wanted to keep this as succinct because there's some other key changes I want to make points on. Part two's got lots and lots of new terms and definitions: prosumers installation, arc fault detection, island modes, EEMS, and we'll come on to that. But one interesting bit that I've put in here, it's not in part two, but I wanted to put it here. ZDB on the certificates, first ever time it's been referenced on the certificates, and you'll see that in a bit. But just going back to hit home the whole prosumer, I'm a keen visual learner. That's you with the bulb, and a prosumer is someone who produces energy from the left via green sources, solar, wind, battery storage, and stores it, and someone who consumes, hence the term prosumer. Okay, so that's what a prosumer is. Now, an island mode, again, please forgive if you're the visuals, but I'm a big fan of visual. An island mode is someone who may have his house switched off from the grid, but can still generate electricity from wind or battery or solar PV. Okay, so that's when you're switched out from the grid, you're in island mode. One of the new introductory terms, a lot of us will know this term, DNO. If you're of a certain age, you'll know it as the LEB or the REC, the Regional Electricity Company. A DSO, Distribution System Operator. And the great visual courtesy of UKPN, who have given me permission to recreate this. This is traditional energy journey. We have large-scale generation transmitted over the national grid into your local DNO network and transmitted to local customers, our homes. And that's what the system was built for in the original 30s. But this is what the future is. And it's not just the future, it's what we have now. So we have large scale generation, but we have large scale solar and wind that are trying to connect, and the national grid have to regulate that energy. And what they're trying to do with this DSO is create a system. So not just a national grid, but a local grid. So eventually your street may have 20 homes, 15 with solar, 2 with wind, and 20 cars. They will end up becoming your own little grid if you lose the network. That's the theory behind it. It's quite exciting and dynamic, but it requires a hell of a lot of thinking outside of the norms from which we were taught as electricians or electrical engineers, because this is coming at a fast pace. Part 4, there isn't anything really changes in part 3. It's probably the most unloved part of the book, but it's one of the more fascinating. But I'll leave you to go and read and analyze that for yourself. Part 4 is where the real meat gets on the bones. It's the interesting bits. Regulation 41112, protective bonding. To bond or not to bond is a phrase used on social media. There you have a plastic pipe with a bit of copper coming off it. Some people bond it, some people do not bond it. Now, the regulation says, and there's a slight change, and that's in brown underlined. In each installation within a building, extraneous conductive parts liable to introduce a dangerous potential difference. Now, there's going to be a lot of debate on what a dangerous potential difference is, because now if you go and get a clamp meter, you may find you have 3 or 4 or 5 volts sitting on your earthing system from other means or normal leakage. So I'm sure there's going to be a lot more development and debate on what a dangerous potential difference is. For us, bread and butter stuff, it's anything over 50 volts, but it's going to be quite interesting to see how that develops, and you'll see why in a while. So obviously anything extraneous, extraneous is not part of the electrical installation, at earth potential, liable to introduce potentials greater than earth. Metallic water pipes, gas, other metallic pipework conducting, central heating, aircon, and metallic structures. That's not changed, that's bread and butter. One of the interesting changes comes at the bottom of the regulation where it says an incoming telecoms cable, which may have a metallic sheath, equipotential bonding should be applied. However, the consent of the owner and operator of the cable should be obtained. Where consent is not granted, and as a consequence, this requirement is not met, details should be recorded in the description section of the appropriate electrical certificate. Now, one of the things that surge protection has taught us is those wonderful little widgets on the right-hand side there, the Virgin Media boxes, that's a coax cable, that's a conductive cable. Do we apply surge protection on that? Is that an extraneous conductive part? So how much thought do we give to that? And I think as an industry, we probably don't. But I'm not an expert on Virgin Media and their telecoms infrastructure, but it just hit me as to, how do I protect against that? Do I box it in? Do I insulate that gland? Is there a widget inside that protects any transients entering the installation? I don't know, but it's worthwhile maybe doing a little bit of research yourself to go and investigate and contribute to that body of debate and knowledge. One of the other things that I have to give you a warning and a careful consideration on, MLCP, it's a plastic pipe, the plumbers love it, but inside it's got a conductive aluminium core to protect it. Well, if that's not installed correctly, then surely that pipe, even though what appears plastic, could potentially be still conductive. And I only found this out from a plumber who came to my house recently, and it was a really interesting thought piece. So just be mindful, if it's plastic, if it's got a core, has it been connected correctly? Do you still want to do continuity testing? Just for a morbid curiosity, if anything else. 41133 in the additional requirements section. So RCDs have been a thing since the late 90s. They were introduced in the 16th edition, and they're a good thing. They're an additional protection, or what they used to be called supplementary. And in the last edition, everything went up to 32 amps. So anything up to 32 amps, a circuit breaker or a device, we would apply RCDs unless you wanted to risk assess yourself out. What they've done is add a little bit of clarity into this reg, and I think it's a great improvement. So what they've said is socket outlets of a rated current not exceeding 32 amps in locations where they're liable to be used by persons of BA, B3, or BA2. And later on in the appendices, there's a little table, utilizations, and it gives you clearly ordinary persons, children, disabled persons. So a little bit of good knowledge there to just make people aware. Utilization, using the people using the installation, think hard, make sure you apply protection to protect those who are not skilled or instructed, the normal general public. So I think that's a good slight tweak and improvement. One of the other things that I love is the note in this regulation. Obviously the risk assessment is still in, but for the purpose of the exception, an ordinary person instructed in the use of installation does not become an instructed person electrically or cease to be an ordinary person. So you may go to a nursery and there may be a caretaker there. Now, just by you telling them, yeah, be wary, do this, do that, that doesn't make them competent to change the risk profile or agree electrical design decisions. And I quite like that, because that's a little bit more firming up of the intensity around the protection required and afforded by RCDs. And any risk assessments obviously got to be appended to the certificate. I don't really see many risk assessments. I wrote one years ago, haven't seen many since. One of the more sneaky, controversial ones, you could argue, is 41142. It's recommended by an additional connection to earth by means of an earth electrode in accordance with chapter 54, the earthing part, is made to the main earth terminal. This recommendation does not apply to outbuildings. So on new builds, it's recommending an earth electrode. Now the image on the right is a conjure disc. Please Google them. I've used them instead of rods because they're safer. They're a bit more expensive, but they're just safer from an installation perspective. And yeah, that's a bit of a naughty one, really. There's been quite a lot of controversy around that, because that earth rod at your installation is generally only installed by the regional electricity company to mitigate supply cable faults. But when you start to look at where the industry is going, when you're switching out your network supply, you're going to need a local earth electrode. So you can see where this has come from. Right, one of the more controversial items that arrived in the 18th edition, 42117, and by the way, it is for earth bonding at the moment, but when you switch the installation out, it will do both. 4117, protection against fire, AFDD. Now, for those who may not know about AFDDs, I flew to Austria when they came out to do some testing with the guys at Eton to understand them better. Effectively, they're a microprocessor that sits in a device and it looks for noise on the waveform. But fundamentally, what they do is they look for series breaks in a conductor, whether it be line or neutral, or parallel breaks, which may not get picked up by an RCD. And what can happen is that break in the conductor can allow temperatures to increase. That then allows the PVC to oxidize. As that copper melts, it causes gas. Eventually, you get carbon. It allows voltage to track. Boom, ignition. You then get a fire. Now, there's some great visuals for learning these, because anyone of whatever age you're learning of, MCBs are your base principle, fuses, MCBs, that's for overloads and short circuits. Your RCD is your earth leakage, or earth tracking as they use in Europe. We then have, in the recent additions, surge protection and AFDDs. I personally think surge protection is a given, and we'll cover that in a second. AFDD, I adopt a rule of thumb of what's the utilization of the installation. Be very careful. This is, to me, an additional protection measure. Who is using this? This is a care home, and we'll get onto that in a second. So it's just a quick example of what, there's a standard waveform, 50 Hertz waveform, and that's an arc voltage and current waveform that was under test, we actually did at the laboratory. And it just shows you some of the noise that can occur on the AC waveform, and the devices are sensitive and intelligent enough to determine whether it's a fault which can cause harm or a normal operating inrush or surge or interference from a connected load. And they're only, that's only 3 cycles of 50. So there's some serious intelligence in these devices. Obviously, fires can occur at points of connection where you've got loose conductors, and in white goods. You'll be surprised to know, or maybe not, that the British standard, or BSEN standard 62606, was written by white goods manufacturers. So rather than putting them in white goods, stick them in the fuse boards, protect the entire installation. So that's where we're going with that, and I'm sure it will come more and more and more. So protection against fire, 42117. AFDDs conforming to 62606 shall be provided for single phase up to 32 amp. Now, in the older regs, the 18th, there was a lot of controversy of what defines a dwelling and a sleeping accommodation. Now they've been a bit more sensible. High risk residential buildings, houses of multiple occupation, purpose-built student accommodation, and care homes. You read them, you immediately can see why. High-risk residential buildings are over 18 meters. That's a debate for fire engineering. We'll come on in a second. But for me, I would use that in my home on, well, I have the rule of thumb, anything a plumber can touch. Immersion heat is high current using technology, and there is a reason behind that, which we'll get onto. But for all other premises, the use of AFDD is recommended up to 32 amps. So it's not mandated everywhere, but just consider who is in that home. Are they vulnerable persons? You know, if there's someone bedridden at home, if I was changing a board, it'd be AFDD every day. Why? Because they can't evacuate. Protect the installation better. Where used, AFDDs placed at the origin. The use of AFDDs does not obviate the need to apply one or more protective measures. You don't just stick them in and not do bonding. It's additional protection. There is a bit of controversy as to whether they will trip or not. So in the standard itself, 62606, they are tested to a minimum value of 2.5 amps. Now, that's not to say they won't work under 2.5 amps, but the magnitude of current needed to form a stable arc has been defined from testing as 2.5 amps, and they guarantee a trip time of 1 second. Now, below 2.5 amps, it's not to say the device won't trip, but it may be a trip from earth leakage rather than the AFDD component. So that's directly from the 6260 standard. Now, 422 has been rewritten quite considerably with an appendix, precautions where particular risk of fire exists. Now, we have available to us lots and lots of case studies and information out there. Please Google Shirley Towers and look at the horrific events there. 2 firemen died from premature collapse of cables, which is why that appeared in the 17th edition Amendment 3. Argued by many, I can't even bring myself to argue over that sort of premature collapse. Harrow Court, very similar circumstances, more firemen died. So 4221, general requirements. It introduces us to standards that some people may not be familiar with, the BS 999 suite of standards. 9991 covers your domestic or residential, 992 does railways, 9999 is your high level. Now, if you're looking at becoming or learning fire engineering better, start with your Part B, go into your 9999 if you can't find the answers in Part B, and then go into your PD 7974, which is, it's all very risk-based analysis for fire engineering. So what the regulation here says is for such locations, the fire safety design of the building should be documented. A lot of places aren't, unfortunately. This information should be included in the fire safety manual produced by the responsible person. That's not you as a contractor. So there's an opportunity for you as a contractor to go in and maybe diversify and offer that as a service or team up with someone who's very competent. But I think you'll find lots of fire engineers are very busy. The responsible person is defined in the fire reform order, and BS 999 is referenced as a very good code of practice to use. It is. It's a great document to read. It's not expecting you, by the way, to be a fire engineer or an expert in fire. What it's asking us to do is consider all those external influences that influence us and how we influence the environment as well, which has always been in the regs for many, many years. It is recommended that the electrical system designer or installer provides the person responsible for the building with the details of the electrical system, setting out the basis of the design with respects to fire safety, including routine maintenance. So, you know, 132, let's consider the design in a lot more depth, so that we can ensure that we're meeting that obligation to enhance the fire safety knowledge. And for anyone who's been watching the Grenfell stuff, that golden thread of knowledge is inevitable. More records required, more detailed, documented. A recent court case that I've been studying, if it isn't written down, then there's no evidence that you did anything. It's a simple but logical mindset. Now, one of the key things that jumped out at me was this: where it's determined that cables should have improved fire performance but are not covered by regulation 422, so for instance in your emergency or protected escape routes, you may use cables with a minimum light transmittance of 60% when tested in accordance with 61034-2 and have limited flame propagation. And you immediately read this and go, oh, I've got to buy loads of standards. No, you don't. This is basically what it is. So one of the main reasons, and my slide is the wrong way around, but I'll just cover this off quickly. Protected escape routes. There is a requirement for protected escape routes, more consideration for evacuation. So that photo there is my holiday home. You can see all the electrics on the top left are all boxed in and secured, and if there was a fire in the corridor, I could go into that exit route and it would be protected from fire via compartmentation, and the electrical installation is only feeding that area. So no services running through, but just for maintenance, lighting, emergency lighting, fire alarms. Here we go. Apologies. So protected escape routes. One of the things that we just briefed on was the light transmittal test. So if we look at 61034, what it is basically, you can see at the bottom of the photo there's a cable 1 meter length under test, and we're looking for the emissions, namely smoke for this. Now, they'll test this for a number of minutes, and after a certain set minutes, can you still see 60% of the light? And there is a monitor on the right hand side that reads the light output. And it's literally as simple as that. We need to be thinking about low smoke emitting, low toxic, fume emitting cabling wherever we go. I use FP600 for most of my stuff now, and it's a big learning journey understanding fire performance of cables. London Underground do have an excellent, world-class approach to it. King's Cross taught them more than most. So London Underground have a great fire performance standard if you're interested in learning more about that. Most people will recognize this flash density map, lightning strikes, and the CRL calculated risk level that was in the 18th edition for overvoltage control, also known to us as surge protection. You will be over the moon to know that it is deleted. Some common sense has finally come on board. And now there is, in overvoltage control, we have protection against transient overvoltages shall be provided where consequences by the overvoltage could result in serious injury to or loss of human life. Failure of a safety service as defined in Part 2, and significant financial or data loss. Now, to me, that's emergency lighting, that's fire alarms, that's pretty much in most commercial buildings. Safety services, what that is in the eye of the duty holder and the responsible person. But it then says for all other cases, protection against transients shall be provided unless the owner declares it not required due to any loss or damage being tolerable and they accept the risk of damage. So there is still a caveat to not do it. However, there are not many clients out there who understand a word that electrical contractors tell them. So make sure you're discharging your duty in a written manner. And I'm sure there are people like the ECA and the NIC and NAPIT who will support you on all these risk assessment forms and templates and all that good stuff. But for those who may not be familiar with surge, nice picture to break it up. Type 1 you generally put on your mains from transient over voltages that enter the building. Type 2 would be at your local boards and consumer units. Type 3 at your more sensitive equipment. In a nutshell, for me, my railway, type 1 is on my mains, every fuse board with a type 2, and then type 3 will be at my ticket machines to protect those vulnerable circuits because I've got 25,000 volts within a few meters. So it's sensible. Moving on with part 5. I've had to remove quite a few bits out of this for time, but there's lots of changes to labeling. You must do it, but on domestic, there's kind of exemptions to not. But the one key point is really that dual colors label that we've had since 2004. We don't have to do it anymore, which I think is probably a good thing because everybody should really know that there were 2 colors 20 odd years ago, and we're moving along with harmonized colors. So that's one of the key things. Regulation 53132, back to RCDs. There is a wonderful regulation called unwanted tripping. It's quite long. But what it says is residual current devices should be selected and erected so to limit the risk of unwanted tripping. It used to be called nuisance tripping. The following shall be considered. So bullet point 1, subdivision of circuits of individually associated RCDs. RCDs should be selected and the circuits divided in such a way that any earth leakage to occur in normal operation of the connected node will not cause unwanted tripping. Now, most people will say this is the death of the split load board. Now, if you think about it, if you put on a domestic house like mine, in theory, I could put a split load type A RCD, measure my leakage, and as long as it's within tolerance, it's fully compliant. However, there is a push or a recommendation, which I wholeheartedly agree with. So some people argue that that's the death of it. I think we'll still see it around for a few years yet, but I do think we are moving away from the split load board. There's your RCBO board. What it also says is residual current devices shall be selected and erected to limit the risk. The use of RCBOs for individual final circuits. So everybody's now going, hooray, whoopee, the deaf split load boards. Not necessarily. Every installation is unique and different. However, I wouldn't ever use a split load board. I've always been a fan of RCBOs for the last 20 years. This is nothing new to me. Yeah, if you're in a vulnerable person's home, why would you put a split load board when one fault, one circuit can knock out all the lights, which could injure them? It's just an evolution of the application of the technology, I think. So we're slowly weaning it out. For those who are probably thinking, what gibberish is he talking about when it comes to RCDs? So many, many moons ago, we all knew RCDs were a supplementary or additional method of protection. And the regulation 53133 kind of introduces us to, obviously we know type AC, which is for standard AC resistive or inductive loads, which is what we've been using for years. Type A was introduced in the 18th edition, and that protects against leakage up to 6 milliamps. And those 6 milliamps, what looks like two weird bumps in the road, is effectively a half-wave rectified DC. We need to learn what these little images are. Type F has up to 10 milliamp protection for AC and half-wave rectified, and also connected frequency interference. And then Type B also offers up to 10 milliamp DC protection, and that covers your AC loads, your switch rectified DC, your connected frequencies, your constant current DC, i.e. battery sources, or your pulsed DC, which can come from control systems, which use pulsed DC signals. So it kind of covers everything. Now, in my opinion, and I'm allowed to give an opinion because engineers, we all have them, I can see Type A being the minimum now. I wouldn't be using AC unless I have an old bar heater somewhere. But I think in the next 5 to 10 years, Type B will be the minimum because of the utilization of DC in installations. But just be mindful, only up to 10 milliamps. If you measure more, and I have recently measured a hell of a lot more, it may not protect your installation at all. Now, when we talk about blinding and stunning, because that's what DC leakage can do, it can blind an RCD. That doesn't mean the RCD doesn't work. What it does mean is it can delay the performance of the device. Okay. Now, only if you've got really bad luck will it completely make it not work, and quite a large amount of DC. In the domestic home, not so much. So that needs to be considered when you're selecting a rective. There's a great European standard that's got some nice visuals that talk about how you configure your RCDs. Please note there's no AC type on these. And anything that's type B, you obviously want to configure it so it's above type A. That way you don't have any DC leakage overwhelming your type A devices. So if you have an EV charger and it recommends type B, make sure you connect it on some Henley blocks before it gets to the board. But a separate boarding. Now, type AC is a controversial device. It was banned in Germany in 1984, so 38 years ago. Austria, Belgium, Denmark, and Switzerland have followed suit. They just banned them. And type A have been available in this country since the late 90s. So they're nothing new. It's just kind of we're playing catch up with ourselves. And mainly because the application of technology, really. So in that regulation, it also has a fantastic argument, which is RCDs type AC shall only be used to serve fixed equipment where it is known the load current contains no DC. Okay, so if you know it has DC components, should you be using type AC? Henceforth, some people will call it the death of AC type RCDs. There's some notes that just gives examples of fixed equipment, and then there's also a guide, PDIEC 62350, which references, and there it is for your speed and brevity. And all it does is it teaches you how to figure out the sum total leakage of the circuit, because in that regulation there is a requirement to not overwhelm an RCD by 30%, which is about 9 milliamps on a 30 milliamp RCD. And all you do is you take the leakage of the connected appliances times by 0.75. So just using that table, if I had worst case scenario, a printer, 1 milliamp, in theory, I could have 12 times by 0.75 gives me my 9 milliamp. So that's how many I could have on that circuit to comply with the regulation. However, we can depart. We can have a higher leakage. It's down to you to define and document what you want to do. But don't worry, you don't have to buy that standard, because Schneider have a document called Earth Fault Protection. And in there, there's lots and lots of information on how to correctly select, and more information in that document than is in the standard. So it's free to download. So please download it and have a read and continue your learning journey. One of the other small changes, earthing arrangements, dual earthing terminals in the back of most sockets. That regulation has been deleted. Quite important. Because now if we comply with the 9 milliamps and the RCD protection and the DC immunity, do we need it? Part 6, very controversial part. There's a requirement for installation resistance. I'm not going to dwell on this too much, but in a nutshell, test it before you connect all the connected loads, and then afterwards you can then join the live and neutral together at a lower voltage, follow the manufacturer's equipment. If you're looking guidance note 3, there is some very good visual guidance. That's been pretty much a rewrite that informs you about smart equipment now, so there's more up-to-date images for us to use and learn from. But yes, make sure you installation resistance test, and if you do it at 250, the requirement of 1 meg still stands, not 0.5. So that kind of covers that very briefly. I'm not going to cover that. So additional protection of RCDs, this is the controversial one. I am writing a webinar on this. It'll take me forever, but I'm getting there. So RCDs, now people think leakage is a new thing. No, it's not. First edition, there's the word leakage. We've always known about leakage. I've got articles going back to 1860 talking about leakage of installations, how you manage and control this thing called electricity and energy. It's always been in the mindset of every edition of the wiring regulations. So just for information, first ever standard on RCDs was BS 842 in 1939. And it dealt with voltage operated earth leakage devices. So we started with voltage, then we went to a current, and now we're kind of working our way back to all bits in between. We're currently sat on BSEN 61008, which is the standard for RCDs. 61009 incorporates overcurrent protection, and we're heading our way to these RCDs, which is the DC mode charger ones for EV. So new standards are being brought out all the time. Technology is running at a pace. It's a real challenge to catch up. But just be mindful that none of this is new. We had DC distribution in homes well over 100 years ago. We had generators in homes before the national grid. So we're kind of picking up on old ways. There is a standard called BSEN 61557, and it's all to do with effectiveness of RCDs. And basically what that does is that says the effectiveness of disconnection by RCD shall be verified using test equipment. In our language, it's an MFT or an RCD tester. So just take into account the operating characteristics of the device. Now, regardless of RCD type, effectiveness, and this is the new regulation that's caused controversy, is deemed to have been verified where the RCD disconnects within the time stated below at an AC alternating current test at rate residual operating of I delta N. So 30 milliamps, it's 300 milliseconds. That's it. As long as it trips at 300 milliseconds, it complies. Now, there's a lot of debate to be had about this. A lot of people could argue and have said, well, BSEN 61008 is a manufacturer's standard, and we've always kind of brought a manufacturer's test into the wiring regulations. There's more to it than that. There's far more to it. This table that used to give us all this wonderful guidance from one of the appendices that told us 300 milliseconds or 150 or 40, it's been deleted. It's gone. It's completely gone. This led to the big problem of all the returns, the great A. So for about 2-3 years now, people have been returning them, testing them, and it's caused controversy because when the CPSs have discussed it, there was recommendation that came out that said test at the terminals. Well, if you test at the terminals, you're basically doing a manufacturer test. When I was taught testing, it was test at the end of line because you've selected and erected that field wiring. The RCD is protecting that field wiring, but what's happening now is the connected loads are interfering with that leakage current. That's you've got capacitors now connected in parallel with these cables, and of course, as you're chucking that fault current down for the RCD to trip, it's not tripping within the times. So electricians are sending it back saying it's failed, when in actual fact it's a connected load and that compatibility issue. So chapter 3 is well worth a read. Anyway, so let's look at table 1 very simply. There are 2 tables, table 1 and 2. For type AC and A, it shows you your I delta N of 0.03, which is obviously your 30 milliamps. And then you've got 5 times I delta N or 0.25 of an amp. Now that's the only reference to that 0.25, and in our language, it's 250 milliamp. This caused a lot of controversy on social media. How do I do it? Do I set my tester to 500 milliamp and half? Where's this all come from? Well, it came from table 1, and it was in the last amendment to the standard. So it has caused a lot of controversy, but this is the one that we need to be looking at now, and this is the reasoning behind it. So where you've got your I delta N at 30 milliamp, you've got that 300 millisecond trip time, and if you look at the top there, you've got I delta N of 1.4. That's 1.4 times the I delta N. So if you look at the bottom there, 1 times 30 milliamp, 130 milliamp, sorry, times 1.41 equals 42 milliamps. And that is what our devices are doing to cause the RCD to trip. Now, some of the documents I've read have discussed the 42 milliamp actually increases the thermal shock, or not, what's the word I'm trying to look for here? It replicates DC via simulating the heating effect that DC causes internally to the RCD, which is why you need more current to produce that same test. But we don't do 5 times anymore. However, in my opinion, and it's only my opinion, please follow guidance note 3, because guidance note 3 still tells you to do more tests. And more importantly, manufacturers, every single manufacturer will tell you a different thing. You are required to follow manufacturer's instructions. You may ask your CPS, but they may not have read the manufacturer's instructions. You are the designer, you have the liability, the due diligence sits with you. I'm going to skip over these. These are the new test forms. So some basic changes. The schedule of inspections has got smaller. There was a question and a regulation for everything. Now it's got a lot simpler. Whether that's a good thing or not, it's in the eye of the industry. That may change again, who knows? The general circuit of details, there's a space for logo, but they're just catching up on where most of the online certification systems already sit. There's now extra bits for set SPDs, the type of the RCD that you're putting in on the schedule of circuit details. The minor works, which I think is fantastic, now has the information at the back has all the information that was removed, the labels that are now don't need to be installed. And part 3 now includes your RCD type, manufacturer, rating current, SPD type, and the BSEN numbers. So great bit of it. I think that minor works is the best it's ever been. And I like the addition of the basic labeling repeated on the back of the certificate, because that's all we need to do in domestic settings, is hand them all the information in a handover pack. Don't necessarily need to label everything, although I have. It's me, it's my industrial mindset. Electrical installation condition report, not really massive changes on that at all, other than obviously the schedule of items inspected. But the one thing that does jump out at us is in the condition report up to 100 amps, we all know C1, unacceptable, potentially dangerous, improvement recommended, further investigation or not verified. But there's a new thing now that requires you to put an X code on the DNO equipment. Now, if you go in and it's live parts, then you would C1 it. If it's anything else, then technically the DNO equipment is outside the scope of the electrical contractor. It's property of the DNO. It's the relationship is between the customer in the home and the DNO. So my recommendation is ring 105, get a fault report number. And also, me personally, this is my personal opinion now, if I went to a DNO head and it was melting, or there was a phenolic issue, or there was a major earthing problem, I wouldn't just leave it. I would do everything within my power that's reasonably practicable. Yes, note it down. Yes, ring 105, but make sure that customer knows they've got to get something done. And I would also check back in as well, to be honest with you, to make sure it's done, because I have an inherent fear that this is to help with the workloads of the DNOs, because this equipment is getting older and older and older. So just be mindful when it comes to working around this equipment. The reason I said that is because Guidance Note 3, which has been rewritten, in section 333 or Appendix D, there's this wonderful check for diverted neutral currents. And if anyone knows me, you'll know I've been blithering on about diverted neutrals for some years. That's an earthing conductor for an installation with 20 amps on the earthing conductor. Even when I isolate the installation, I can still get 20 amps. So it's network neutral current, finding another path. And so I've done a simple diagram for what that actually means in simple terms. So this is a normal house, 3 houses in a row. You've got a substation feeding and a PME or a TNCS supply. So you've got your live going out and your combined neutral and earth into someone's home, and you've got a nice little 4-way earth block. And you've got a bond to your water and your gas main. That's probably 95% of modern homes. So in normal conditions, everything works, no problem. Then over time, that cable, which could be a 70-year-old plus PILC lead cable, some could be doing groundworks, or it could just wear and tear. It could go faulty, it could go bang, it could just, it could be an old joint that just breaks down, goes high resistance, and eventually you break the neutral. And then what happens is the current that's trying to get from number 3 back to the substation will divert on the water or gas main into 2, some into 1, and work its way back. And that's a phenomenon known as imported or diverted neutral current. That's the imported version. Exported is this: single dwelling, transformer, could be on a pole, combined neutral and earth, break on that neutral, it's going to use whatever parallel low impedance path it can. Okay, and then somebody maybe a few miles away may pick it up. So that's diverted neutrals. It's really important because of this. So I've done a freedom of information request, and this is the Health and Safety Executive broken neutral reports up to the 1st of March this year. It's, as you can see, there's a trend of going up. This year alone, 68 within the first basically 2 months. That's the stuff that's reported. So expect these to go up and up the more people have knowledge of it. My advice, if you're working on a DNO head, use a voltage, a contact voltage indicator. Make sure you're wearing gloves and have a clamp meter. And that's the recommendation in GN3 for the clamp meter to check for this. Not necessarily saying it's dangerous, but it's something that the networks need to manage. We just need to do our bit by informing people. Moving on to part 7. I'm not going to go into this in much detail, but for those who find this exciting, the regulation has changed to remove the socket outlet minimum distance from 3 meters to 2.5. Apparently it's got to do with harmonization with Europe, but I can't find it in any European standards. So 2.5 meters is the minimum now for a socket outlet in a bath. There you go, that's the big change. Solar PV, that has had extensive changes, and this is the sort of thing we're going to be seeing quite a lot. And I do mean quite a lot. This is an installation on my railway. I quite like it. It's got some DC isolators. It's then got a solar inverter. It has DC surge protection at the bottom. It then goes out of the inverter into the trunking into some AC surge protection, and then via an AC isolator off to the electrical installation. There are requirements now within 712 to have correct isolation, surge protection considerations. This has all come from the BSEN standards. Now, your inverter could do this. but from my safe system work perspective, I want my electricians to be able to isolate the DC safely, isolate the AC safely, and then remove the product in between. I don't really trust the plugs. Sometimes the plugs can go wrong, and sometimes the installations can go wrong and the strings can melt. There are also requirements for consideration of sizing of DC cables, protection against mechanical impact, UV degradation, etc. So solar PV is leveled up. It's very specialist, but it's worth knowing because it's here to stay. One of the other outdoor lighting installations changes, I just wanted to put this example in. There is additional protection. It's always been in there, but they've included examples now. And one of the key points that jumps out is gardens and spaces to the public. That was driven by the sad tragedy of Harvey Terrell, 7-year-old, who was climbing on a pub fence and sadly got electrocuted. I won't comment on the owners of the pubs and all the legal stuff, but you can think, you know what I'm thinking. So that's a positive as far as I'm concerned, a change to protect people's families. That's a good thing. Whew, electric vehicles. Moving on to an EV. We're not going to escape this. It's happening. It's here now. So one of the interesting bits, we obviously had Amendment 1, which pretty much rewrote and brought this 722 to us. There's a section 722.41141 where equipment is to be used not covered by a British or harmonised standard. There is obviously a risk that we're not complying with low voltage directives or supply of electrical equipment regulations. So it's responsibility of the electrical installation designer or person responsible for specifying the installation to ensure or establish, apologies, the equipment meets the requirements of the electrical equipment safety regulations and the EMC regulations. The equipment has either a CE, UKCA or UKNI and a declaration of conformity. Now I've asked manufacturers for this and the silence is deafening. I don't know if there are fully compliant products. I am sure that there are lots and lots of EV chargers that are full compliant. This kind of has been controversial around the broken neutral detection devices, which looks upstream for failures in the network, which is a good thing, but there's no BS or BSEN standards from them for them. So that then introduces a level of risk. How do we say that we're compliant with the electrical equipment safety regulations? We're going to need to do some due diligence and maybe ask them for their technical files and evidence that they've taken every reasonable step. And also the declaration of conformity is to be appended to the certificate. How many people do that? So I think this is a good change. Kind of other bits, very minor, making sure that people are very clear. RCDs of type A, F or B or 30 milliamps are provided. I think there was a bit of confusion with 722 when it last came out, so they've just reworded that a little bit to ensure that nobody's putting AC on these EV chargers. Now, that is St Pancras Station in 1912. Don't worry, that ABB RCD wasn't there then, but that's electric vehicles in St Pancras. They took over from horses all them years ago. So electric vehicles are not new. They're not new at all. However, we've obviously improved from fuses and we're now putting in RCDs, but not AC. That one's an AC, so please don't put AC RCDs in. They're banned. We don't like them. This is kind of the thing we're going to be looking for in the future. This is the thing that excites the electrical contractor. Beautiful, brand new car parking facilities with lots of EV charging capability. This is the future, whether anybody likes it or not. EV is here to stay. Whether or not cobalt and all the materials necessary to make batteries are here to stay forever is another question. But I think for the next 20, 30 years, there's going to be a lot of mileage in EV. This is the sort of things we may be seeing in certain homes: battery storage, EV, solar, wind turbines. It's an exciting time for the industry. It's an exciting time for learning. This is why I'm trying to impart these sorts of things so that people can be excited themselves and go away and do some learning and maybe do some training and maybe diversify their contracting ability or just their general knowledge. Part 8 is a key one, and that kind of takes us into net zero. So part 8 at the moment, as it stands, chapter 82 is part 8, but I didn't want to do just chapter 82. I wanted to introduce you to how this links to net zero. So chapter 81 will be in a future edition of the wiring regs. It actually says in appendix 17 it will be in the future. It started off with a harmonized document or a BSEN 60364 standard. If you ever want to know what's coming in the wiring regulations, just go in and look for 60364 1 2 3 4 5. It's exact same as our chapter and numbering system, and when they update, then you know there's a potential change coming. So Chapter 83 will come in future, and that is called Operation of Prosumers Electrical Installation, or Evolution. So let's go into it. So Appendix 17 is 78 pages of the standard into 6. And what it does is it starts whetting the appetite for this energy efficiency of your installation. And that's really important. So it talks about energy efficiency effectively in 6 pages, and it introduces us to these categories. So energy efficiency 0, 1, 2, 3, 4, and 5. And what it does is it allows the designer to, or the assessor, to assess and give points based on the number of design considerations for saving of energy. So increasing the size of the cables to reduce losses, putting transformers, if it's commercial industrial, central so that the cable lengths are reduced. And you can score based on what you do. Plus, there's obviously bonus classes, which we'll see in a sec. But this also introduces to the term of the energy manager. Is this another person, or is it me in my day job? Don't know yet, probably will be. But the energy manager is a key part of that. Now, Appendix 17, I don't expect many people to read it because it's right at the end of the book. But it does have some very interesting diagrams that are available, how we energy audit, how we add that into our process, how we set the basics, how do we optimize, how do we monitor and maintain, how do we control and improve. So it really is a different part of 7671 now. Chapter 8 is behavioral, continuous improvement, monitoring, checking, good design practices. It's a really holistic, when it's fully complete, it will be a very holistic section of the wiring regulations. It introduces us to the Barry Center method. I used to think that was a bloke called Barry who just said stick everything in the center, but no, he came up with some really clever equations based on GPS coordinates and all sorts, so, and efficiency measures. So there's lots of stuff like that, and we're going to need a course to understand all this sort of stuff. So I know CIBSI do energy manager stuff, and they do cover this. Part of the scoring system you can award points, determination of energy consumption and local of sub-main station, volt drop, efficiency of transformers, as I've said, power factor, looking at harmonics, renewables, Brucey bonus points, electrical energy storage. You can see where everyone's going for the bonus points straight away. So all this scoring is in time going to become more and more prolific as we go on that journey to net zero. But chapter 82 is the new part, and that covers prosumer, that producer and consumer. As you can see, that very happy person who takes from the grid and produces their own energy, which is fantastic. It's known as a PEI. In the regs, it's a very simple example. If you look at number 1 on the diagram, public network to effectively home appliances. That's your traditional route. 7 to 3, it's your renewable energy sources into an inverter, and then obviously into motors if you want to do that in your offices. Then you've got wind turbines, AC to AC, into your lights. You've then got generators or ground source heat pumps, sorry, to your radiators, battery storage to AC, your car being also a battery storage. So any combination you want. Island mode, as we know, the installation is connected. So it defines what island mode is. It's disconnected, but it remains energized. And that's a first, because normally if you did that, you were departing from the regulations. Now it's in the regulations. It allows that. Connected mode, I don't know why they came up with this, but it's just a definition. It's where the prosumer's electrical installation is connected to the grid, which is what we do every day. Direct feeding mode is where the grid supplies your prosumer's installation of energy, so it could be a bit of both, feeding it. And then reverse feeding mode, where your prosumer supplies the grid and you get paid, which was the mad solar rush of 10, 15 years ago. Stick some panels up and earn a fortune, and those incentives are now, I don't think they're very incentivized anymore. So that's reverse feeding mode. So these are new terms now for the operation of electrical installation. Now, there's a new term called EEMS, and EEMS is going to be everything we do in the next 10, 20, 30 years. And what that deals is with connection of the prosumer's installation to the smart grid. It manages local energy production, manages local energy consumption and energy procurement. Some of us know them as smart meters. So smart meter will be a tool. Now, if you look here at an extract, this is an online website at the National Grid's general energy consumption. You can see the peaks and the troughs of energy consumption, where obviously we incentivize people to use energy at night. And if you look at some of them troughs, it's between about 10 o'clock till 7 a.m. Is there anything we can do to encourage, a better load profile nationally? We've got to be smart at everything, including the grids, our home usage, our street usage, usage of our neighbours. It's going to allow for some configurations that we've never really thought of. What does this look like? Well, EEMS is going to eventually do everything. Your battery storage, your recycling, your solar, your wind turbines. It will control your home. It will make it smarter than we ever thought it could be, but it will be there to protect you and protect the grid. I'm not going to say it's not without its potential bugs, but that's the theory. So with EV under prosumer, it's both a load and a storage device. It is not permanently connected because it's on a plug and socket, but it should be managed by the EEMS, the Energy Management Storage System. So a lot of EV chargers are future-proof, the ones with those little twisted pairs for telecoms to enable it to talk, to understand the load profile. But this is not new. This is stuff that some installers, a lot of installers have been doing for some years. It's just the regs giving us a little bit of a clearer line now. Obviously, there's been a lot of requests and questions for it. It kind of leads us on to net zero. Now, the operation of prosumer stuff is still in the draft, so I'm not covering that, but it's just more information on top of that, and it deals with layering and smart grids and interconnectivity of the systems and ensuring that your connected TV, if possible, or if necessary, can be switched off to protect your supply network. So everything's working in synergy. It's quite a dynamic way of looking at grids. Net zero, 2050. So we all know, because we've watched Sky News and BBC News, that net zero is the buzzword. Lots of world leaders went to COP26 and they talked about how can we lower our emissions. Now, forgive me, I'm a bit of a cynic here. I think most good engineers are all cynical. It's trust but verify. It's gone viral. This whole word has just gone viral. What is net zero? So I've been on a journey trying to understand it, and it is a Pandora's box of strange documents. It's confusing. When you first look at it, it's really confusing. Why? Because you see net zero by 2050, decades of inaction, green colonialism, deflection, marketing, eliminate emissions, economic stimulators, more harm than good, greenwashing, false targets, and next generations of problems. These are all terms in my research that I found, that I went in to look, and they were all opinion-based. I think it's inevitable what we need to do with net zero. So what is net zero? Well, according to the Office for National Statistics, net zero means the UK's total greenhouse gas emissions would be equal to or less than the emissions the UK removed from the environment. So it's not saying we're not going to pollute, we're just going to make sure that we remove as much as we put out. So we're effectively neutral. I assume it's to allow the planet to heal. Whether that can be manipulated and traded, I'm sure. I've read enough on it to my spider sense to tingle. But this can be achieved by a combination of emission reduction and emission removal. So what's included? There is a piece of legislation came out that warrants all of this, and in that legislation it includes greenhouse gas emissions or removals from. So the people who are included are businesses based in the UK, regardless of where in the world they are registered, the activities of people that live in the UK as well as non-UK visitors, and land such as forest, crop, or grazing land. So anything that emits greenhouse gas from them must be managed and monitored and controlled under these new regulations. So there's also exclusions from this legislation, and strangely enough, the exclusions are international air travel, international shipping, UK residents abroad, UK Crown dependencies and overseas territories, the burning of biomass, because there is biomass production for energy, land such as peatland, and the production of goods and services that we import. I'll let you talk about that in the comments, but that's the exclusion. So there's some pretty big polluters in that. Effectively, this is how I sum it up. It's emissions versus removal and making sure we've got a balance, basically. It doesn't help if we destroy the rainforests and the coral reefs because they're excellent at storing carbon naturally, and obviously removing a lot of those harmful things and producing the oxygen we need. Net zero, some nice visuals for you. So high emissions, we're going to be doing more emissions in the future to produce all of this smart technology, this green technology, to get the most efficiency we can, which should in theory offset emissions, which should then lead us to net zero. And we've got till 2050 to do it. These are the statistics to date, which show the mass of air emissions in millions of tons. And I think we've done quite well since 1990, considering we were just under 800 million, and we've reduced that to 460. So we've got a way to go. But what you're all thinking is we've done LED, we've got catalytic converters, we've done lots and lots and lots solar. What more is there to do? I genuinely think, in my opinion, it's going to get tougher and tougher. And this is why we're looking at boilers and everything now. It really is going to get tougher. But you can research that for yourself. It's an excellent report. It's on the Office of National Statistics website. What does a net zero home look like? Well, you may have a wind turbine, you may have solar PV electric, you may have solar water. You will have data connected appliances, maybe power over Ethernet. You may have DC connected, you may have air source heat pumps. We're going to have smart connected homes, incredibly smart. Now, I don't actually know who can afford these because I can't. But it's not just the electrical side, it's everything. Efficient lighting, air filtration and ventilation, insulation, low flow water fixtures, high performance windows, floor insulation, efficient appliances. There is a draft, I think it's a published document, it's a draft British standard at the moment that's talking about increases of energy efficiency. So a 10-watt light bulb will have to be a 1-watt light bulb. That's the sort of efficiencies we're trying to squeeze out of the system. Of course, it leads to other issues, you know, harmonic interference and various other bits, but that's what it may look like. And these are sorts of things we can do now. LED, insulation, smart controls, triple glazing. I think triple glazing will be the default. Everything I've read, that seems to be the default facto going forward. So where I'm nearly finished. One of the interesting slides, the Office of National Statistics. This worries me quite a lot because the UK's carbon footprint is classified as an experimental statistic due to inherent uncertainties in the estimates produced. The methodology used to produce them is subject to ongoing review and refinement. It's a theory, but everybody needs to contribute. Everybody needs to contribute. And this is why I see this as this wine regulations as a phenomenal trampoline for people to jump into understanding this better. And two parts of that jigsaw already in Appendix 17 and Chapter 82. Now, in case you're thinking, oh my God, he's waffled, there's loads of information, where do I find it all? Do not worry. If you want to continue ongoing CPD, I've spent days and days looking for this. That is the Climate Change Act that I have referred. That is the instrument which is requiring us all to do as much as we can, but not if we're abroad. There are lots of House of Commons briefings on Brexit, energy and climate change. There is a Build Back Greener paper that is quite interesting from the government. There is also the electric vehicle infrastructure strategy with billions of pounds being invested into this electric vehicle charging infrastructure. There are questions on whether the grid can cope, and the National Grid have said it can cope. Whether the DNOs can cope is another question. There's an EV Energy Task Force that have done some really good work, by the way. This is people researching and giving you this knowledge for free. So if you just look at these, and if you're on YouTube, just Google them, you will find them for yourselves for free. I did laugh at this one, bus back better. So I was at a meeting that I cannot tell you about, but I can say a few things, and that is to achieve these targets, it is expected that 40% of the workforce will be either expected to walk or cycle to work to achieve this in the statistical assumptions that have been made. So you can see these documents exist. I don't think many people know about them, but now you do. Please read them at your own leisure. One of my biggest fears for this carbon capture is this paper here, which is an industrial strategy. But if you look at Kemper in Mississippi, in America, they built this carbon capture power plant, 7.5 billion final cost. It's not performing. If you look at Gorgon in Australia, £3 billion there, and it's just totally underperforming. So the government have, I think it's a £1 or £2 billion pot for people to do carbon capture, and that document will give you all the information if you want to go and bid for government money to do carbon capture. They need every idea, every bit of help we can to achieve this goal. It's an exciting time. I want to credit BEMA massively. So BEMA, God bless them, they have leveled up. And this is a fantastic document called Home Electrical Infrastructure of the Future, How Net Zero. These people are phenomenal. They are serving the industry well, giving us that knowledge and thought pieces for free. And it has some great domestic, great visuals of what the home will look like, and the new term for the fuse board, domestic energy center. That's what we may be thinking of it in the future. And you've got EV, PV, future developments, energy out, battery storage, absolutely fantastic, and lots of secure data connections with it. Now, if you want to learn more, the IET have an electrician part of their website where they do CPD webinars. I think I'm hosting one soon. Battery storage, learn it for free with the people who wrote the book. Lots and lots of CPD webinars there from the IET, so I highly recommend you check them out. If you want to do some courses, I've just done the Smart Grids course, and I highly recommend it. It's incredibly insightful as to how our mindsets and behaviors need to change to open ourselves up to accept this is exciting future. So IET Academy, please check them out. If you want to listen to me waffle more, or this in a far more longer drawn out debate, I have a YouTube channel. Just look at Team Electrical E5, and there's lots of weird and wonderful, unique pieces, hopefully, that will give you some independent knowledge, including the first edition of wiring regs. And of course, I cannot finish without giving all credit and all thanks to the team at the IET Essex network. And we have a YouTube channel, which this will appear on. And feel free to ask questions or look at all of our previous webinars that we've done, and we have many more to come. And other than that, I am going to say thank you very much. My throat is killing me. Q&A time. Oh, it's better.
Right. Good evening, everybody. Again, but we'll hand over to Alan to do the Q&A. We haven't got many questions at the moment, which surprises me.
So I was too fast. Didn't give them time to.
But there's no doubt a few will start coming in now. So over to you, Alan, please.
Right. Thanks, Rob, and thanks, Paul. First of all, say that there's a number of comments on the chat saying how much people appreciated the presentation. So thanks for that, Paul. One or two of the questions are very, very detailed. I'm tempted to skip them because they may not go down very well. I may even misread them. Also, there's all the usual questions about will the slides be available, and the answer is yes. CPD, certificate slides, and the recorded video itself will all be on the IET website under the Essex network. So the first question I'm picking is, what's your view on, this is from Chris, what do you think the driver is for requiring AFDDs on circuits up to 32 amps and not beyond?
There's nothing stopping you. Oh, actually, the standard actually goes above. So 62606 goes above 32 amps. I think it goes up to 63 amps if I remember rightly. But there's nothing stopping you at all. The reason 32 amp was chosen is because the most common fuse in most homes of a certain age is 32, your ring main. So it was decided if you have a ring main, then fine. But if you want to put a 40 amp AFDD on a shower, do it. Most showers should fit within the 32 amp now anyway, to be honest with you. But if you want to do that, do that. There's nothing stopping. Remember, the regs is a minimum standard. It's for you to apply your engineering judgment. So if you want to go and find a 40 amp one, go and find a 40 amp one. There's nothing stopping you. Remember, in the hierarchy of legislation, the wiring regulations is still a guidance note. It's just a guidance note you need to know really well so you can have a defence in a court of law.
Thank you, Paul. Right, next question. I work in a college. Would you suggest that learners that have recently completed the 18th edition prior to the new amendments would need to do an update course to cover all these changes?
Okay, very good point. So on the last amendment, I would have said no because it was very specialist. On this one, given the volume of changes, I would say yes, and I am actually sitting my exam this Friday for this. So I am ensuring that my underpinning competency is demonstrated in a Seating Guild recognised qualification. So yes, when there are major changes to the regs like this, I certainly would recommend it to demonstrate. If you say, oh, I know the regs, that's great. Demonstrate it with your skills, your knowledge, and underpinning qualification won't go amiss. So yeah, my recommendation is yes.
Right, Kevin Field asks, can the current crop of smart meters SMETS 2 cope with a prosumer environment?
I'm going to reserve not answering that. I have a view on smart meters. I think smart meters are yes, I think there's had its teething problems. I don't have a smart meter at the moment. I won't for some time, but I think in maybe 5 to 10 years they'll be ready. But a lot of them have, the newer ones, I know they do have the capacity to cope with all this. I haven't yet seen a paper that says how all of this will magically occur. So if I put solar on this roof and all my neighbours do it, and in theory my local DNO could switch my street off for a week, and we could potentially generate and consume our own energy, and our meters should do all that in theory. I don't know many places that have done it yet. It's exciting and nervous times, but I'm going to reserve judgment on smart meters for a while. My main concern around them is the installers and the competency of them, rather than the technology, to be honest with you.
Okay. Right, question from M. Woodcock, and this is one which I know keeps coming up when people talk about grids and rotating inertia. So this one, I'm all for wider adoption of renewable energy. However, as an electrical engineer, I believe there's some major challenges to overcome with the national grid, e.g. removal of power stations equals loss of rotating inertia and the ability to ride through network faults. So please would you comment on that, Paul?
Ooh, it's a good one. That is a good one. I have quite an issue with this when the use of batteries as a sole means. One of the things that I've always said, and some of my guys who work with me on the railways, we have UPS's battery systems on railways for many years to run the emergency lighting systems. But one of the key things that gets missed is when there is a fault on the system, having enough inertia, enough fault current to operate a protective device still. And one of the things of Section 8 that is very clear that it needs to be, and I could have expanded on this a lot more, there is a requirement to ensure, if you are a prosumer, the minute you switch out the national grid, your fault current levels can still disconnect, that your polarity, your earth loop impedances, all of them still ensure a safe installation. But more importantly, you're going to have to switch your earthing out. So you may end up having characteristics of supply switching rapidly. I am doing my battery storage course next month, and I have been researching this heavily, but I want to get hands-on with it. I think there may be a few challenges, but like with any new technology, there's always teething problems. But I don't disagree with you, because currently we rely on the good old fault current of the grid, and we've spent the last 10, 15 years reducing the load to protect it, and all we've done is free up capacity for EV chargers that can act as their own fault current now. So it's there's a different mindset required from everybody and more guidance. So please, if you've got any lessons, share them with the IET, share them on socials, share your experiences, because that's how we all learn. But yeah, I don't disagree with you on the inertia front at all.
Okay, thank you. This is a slightly more specific question, but we'll try it and see how it goes. So this is from Kyle Wilson. For the update to 411.3.3, we would normally design for RCD protection on items such as roller shutter door supplies, as they would normally be provided with a 16 amp C-form socket. Under the new regulations, I expect RCDs would not be required on these types of installation.
We would normally design for RCD protection on items such as a roller shutter supply. They would normally be provided with a 16 amp C-form socket. New regulation, I expect I would still have that on an RCD. Unless you decide to depart from the regulations of a risk assessment, especially with roller shutters, moving parts, cables that could be entrapped. Why wouldn't you? If you, Carl, you can type some more in there. That'd be great to understand your mindset with that. But yeah, as far as I'm concerned, is RCD protection still required? Yes. Make sure it's the right type. You know, if you do have a motor connected to it, is it one that's just purely resistive, or is it one of the new electronic types? Do we need a type A on it? They're the questions you need to ask the manufacturers. But for me, RCD protection on the roller shutter, absolutely. It's a given. If I can understand more, great. If you want to get in touch with me separately from this, I'm not hard to find. Find me on LinkedIn.
Yes, I'd say please try and make contact either via LinkedIn or via the IET. You can forward emails. So I'll take that as the final question, but just note that while we've been going through the Q&A, there have been so many more thanks messages coming up, and I'll hand back to Rob.
Thank you, Alan. So thank you, Paul. That was brilliant. Everybody seemed to be thoroughly enjoying it from the comments that came up in chat. So greatly appreciated your time in putting that together. And for the colleague in Poland, we did start at 6:30 British summer time. So sorry you missed it by confusion over times. Don't think there's anything else. So good night, everybody, and hope we'll see you at one of our future lectures after the summer holidays.
Thanks, everyone.
Yeah, good
Bye-bye.
night, everybody.
Cheerio.